In today's Daily Dose of Math, we have a question where two functions are given, but each in the form of a table of values. So we don't know right away what type of function each is. For each, we're being asked the same question. What is x if y is 20? Notice we're not being given an x and asked to plug it in to find y, which happens a lot. It can happen in the reverse order as well. We're given a y of 20. We have to plug the 20 into the y position in our equations. But first we have to have equations. And we don't know if these are linear or inverse. So we're going to do the tests to see which they are. Constant difference test with the first one. We take the second y and we subtract the first y. -2 minus -1.5 equals -0.5. And then we do it again with the next two. -3 minus -2 equals -1. We're not getting a constant difference. Notice that this test will only work if the x values are increasing by the same increment, but they are. They're going up by 5 in each case. Let's do the third one just to see. -6 minus -3 equals -3. I have more evidence that this is not linear. So, am I going to assume it's inverse? No, I'm going to do the test for inverse, which is the constant product. This time I don't do two y values together. I multiply the x by the y. -20 times -1.5 is +30. -15 times -2 is +30. It's working. -10 times -3 is +30. -5 times -6 is +30. We are passing the constant product test, and we know that this is inverse. So we say so. What's next? We need to find the equation. Well, finding an inverse function's equation is very quick when you've already done this test, because that answer that we keep getting when we multiply is our a. The function has to have the form y equals a over x. This one will be y equals 30 over x. We're replacing y with a 20 to answer the question. 20 equals 30 over x. Then we get to this weird situation in algebra that you often haven't encountered very much before you get to this type of function, where the variable is in the denominator. But we can do what I call the trade. We can trade places with the 20 and the x. So x is equal to 30 divided by 20, which is 1.5, and I have my final answer. There is no unit of measure to apply because the situation didn't explain what x and y represent. We don't have a unit of measure. Now we can move on to b, and we're going to do the same process. We start with the constant difference. We check to see if the x's are going up by the same increments. 2, 4, 6, they are until here. We go 2, 4, 6, 10. The last one is not going to help, so we're not going to include it. We do -7 minus -11. And we get +4. We do -3 minus -7. And we get +4 again. We have a constant difference, so this is linear. And I say so. Now I need to find its equation. And to do that, I'm going to need to do the slope formula. I'll use the point with x equals 4 and the point with x equals 6 for my slope formula. So, -3 minus -7 over 6 minus 4 is equal to 4 over 2, which simplifies to 2. A is equal to 2. To find our b, we'll take our form y equals ax plus b. We'll replace the a with a 2. And then we use any point we want. I'm going to use the first point, 2, -11. -11 equals 2 times 2 plus b. -11 equals 4 plus b. -11 minus 4 equals b. So my b is equal to -15. And my equation is y equals 2x minus 15. Now I plug in y equals 20 into this equation. 20 equals 2x minus 15. 20 plus 15 equals 2x. 35 equals 2x. We divide both sides by 2 to isolate our x, and x is equal to 17.5. Again, we have no unit of measure to apply, so that is our final answer. So what is the process that we're doing here? We're showing that when we're given a table of values, we are able to figure out, by doing these tests, what type of function it is. And then once we know what type of function it is, we are able to do the math that's required to find the equation for that type of function. And then it becomes easy to answer the final question. We just have to plug y equals 20 into that equation. This is really what we learn to do when we study algebraic modeling. We will learn to do it with several different types of functions, but for the course that I'm making this video for, we're only working on the linear and the inverse so far. So you have to be able to know the difference between them and then know the appropriate math to use once you have decided which of the functions you have. That's today's Daily Dose of Math. Please like, subscribe, and share.